Okay, so welcome back to another video. So today we have a trigonometric integral from 0 to pi over 2 of x squared times x cosine of x minus sine of x and then divided by x squared plus sine squared of x quantity squared then dx. So for an integrand like this, we're going to have to be a little bit creative since there's some things that we can actually rewrite in a way that we will be actually using a u-substitution such that utilizing that will actually cancel out some things that will make things a little bit easier to work around with. And then furthermore, that as we approach throughout this process, we're actually going to be using some sort of integration by parts and utilizing a bit of partial fraction decomposition. Not really a whole lot. It's only just that one step. And then the simplification is just, plug in the values and we get our value from there. So not too much. I think this integral is just interesting, kind of just, because of everything that's all over the place. But there's some things that we just have to, use some tricks such that we can actually write it that it makes things a little bit easier to work around with. So with that out of the way, let's actually jump right in. So to start off, there's this integral, so that means from 0 to pi over 2. So let me actually first write out our numerator. So that's just going to remain unchanged. And then our denominator, when I factor out the x squared from inside this quantity, so I have x squared and then multiply by 1 plus sine square of x and then divided by x squared. And then all of this is being taken into account. This is the quantity squared and then dx. And then what I can do is that after squaring for over here, so that means we'll have an x to the fourth. And then what I'll do is I'll actually divide that x to the fourth from both the numerator and denominator. This will yield us the following. So pi divided by 2. Of our numerator, we'll have x cosine of x minus sine of x. And then divided by the x to the power 4 that we just factor out from here. So that will just cancel out that x squared, will just leave us with x squared on the denominator for the numerator. And then under here is that this is going to be just 1 and then plus. And I can actually unfactor out the square. So that means put that as a quantity as sine of x divided by x and then quantity square. And then we still get a quantity square over here and then dx. So now let's actually perform our u-substitution. So we're going to we'll let this be the inside over here. So sine of x and then divided by x. Then du, so that means we have to apply the quotient rule. So that means skipping all that step. What we'll have is x cosine of x minus sine of x and then divided by x squared and then dx, which is great that we can actually just substitute this back in and then some things just cancel out very nicely. So now don't forget we have to change our bounds over here. So let's see if I plug in pi over 2. So sine of pi over 2 is actually just going to equal simply just 1. And then divided by pi over 2, I'll actually flip the numerator. So that means now that our new upper bound is going to be 2 divided by pi. And then if I were to plug in 0, well, notice that we have a limit of a 0 over 0 indeterminate form. So if you were to take that limit as it approaches 0, we actually know that, it's a well-known limit such that this is actually just going to approach 1. So that means our bottom bound is going to be just positive 1. And so if I actually just substitute everything back, so that means I have du, so everything to here is just cancel, and then divided by, so now I have 1 plus, and then that's going to be u, 1 plus, and then, well, u square specifically, and then quantity square again. Okay, so with this in mind, so now here's the thing about this one. The tricky thing about this is that standardly, you probably want to do something of more of a trigonometric substitution, but you have to know which works. So you have to plug in the right trigonometric substitution to, utilize that shortcut. Well, really, to make things a little bit easier, and it might take a little longer than it does the trigonometric substitution, what I'm going to do is I'm actually going to rewrite it such that I have we're going to divide a 2u, a negative 2u, from both the numerator and denominator. So now our new rewritten integral, so it's 1 to all the way up to 2 divided by pi. And so I have negative 1 divided by 2u, then times negative 2u, and then divided by 1 plus u squared, and then quantity squared, and then du. Okay, so now what we can do here is now let's actually perform some integration by parts. So we just need to choose our u and our dv, which we need to, respectively differentiate and integrate. So for our choice for, now because I have a u over here, so let's actually choose a different variable. We're actually going to call this w. So let's actually choose w. We'll actually let this be negative 1 divided by 2u. So if I differentiate, so dw is going to equal 1 divided by 2u squared and then du. Simply just apply the quotient rule. And so we choose our dv's, we'll let this be negative 2u divided by 1 plus u squared and then quantity squared du. And so if you integrate this, so we have that v is going to just be 1 divided by 1 plus u squared and then du. Okay, so now with this, now we're just actually plug in our integration by parts formula, u times v, or rather w times v, and then with v and then times dw. So putting that back together, so now our new integrand so far is going to be that I have now negative 1 and then divided by 2u, and then we just plug that back in. So that means we have 1 plus u squared, and then we evaluate our bounds from 1 to 2 divided by pi. And then next we have is that, so we plug in our, our v times dw. I can factor out the 1/2 over here, so that means I have a 1/2, and then now our integral again is from going to be 1 to 2 divided by pi. And so with this, we now have 1 divided by u squared, then multiplied by 1 plus u squared, and then du. All right, so now what we have to do is let's actually just plug in this bounds over here. So let me actually switch to a different marker. So then everything over here, so I'm gonna put the brace over here. So now if I just plug in, so that means this is gonna be, so negative 1 and then divided by, so let's see, 2 and then 2 divided by pi. Then now multiply by 1 plus, so 2 divided by pi and then quantity squared. And then we subtract this, so rather it will become a plus, so plus and then 1 divided by, so 2 times 1, and then now multiply by 1 plus 1 squared. And then now we actually simplified this out. So this is going to yield us with just 1 over 4. So I actually just put this positive term in the front. And then now putting back together, so that means reduce this to 1 divided by, so what we have from this term over here specifically, so is 4 divided by pi, and then multiply by 1 plus 4 divided by pi squared. All right, and then let's just simplify things a little further. So if you actually do all this all together, so I have 1 divided by 4 and then subtract pi cubed and then divided by 4 times pi squared and then plus 4. So with that, now we actually have to now deal with this. So what we do here is that let's actually, so let me actually write this out for our value. So 1 divided by 4, then subtract pi cubed, then divided by 4, then times pi squared plus 4. And so now subtract our integral, so 1/2, and then multiply the integral from 1 to 2 divided by pi. Then what we can do here is let's actually rewrite our numerator. So this is actually the same thing as applying the partial fraction decomposition. So I actually just skipped that step and let you guys try this out. So in other words, this is kind of similar to like a add and subtract a 0 term. So what we have is 1 plus u squared, and then we'll subtract a u squared over here. So we have u squared and then 1 plus u squared and then du. So because of this, we can actually now cancel out some things and then apply the linearity. So everything together, so it's 1 divided by 4 minus pi cubed and divided by 4 times pi squared plus 4. Then now subtract, so 1/2, and then multiply the integral from 1 to 2 divided by pi. First stop, so that cancels. So I have now a 1 divided by u squared and then du. And then the next thing is that, so subtract yet again, but that actually changes that to a positive. So now it's going to be plus 1/2, and multiply the integral from 1 to 2 divided by pi of now 1 divided by 1 plus u squared then du. And as you notice, they'll actually makes these two integrals are actually very easy to calculate. So now continuing forward, so 1 divided by 4 minus pi cubed divided by 4 times pi squared plus 4. Then evaluate this integral over here. So what we have is that this is going to be, so minus 1/2 multiply by, so antiderivative is negative 1 divided by u. Evaluate this from 1 to 2 divided by pi. And then the other one is plus 1/2. This one is actually, its antiderivative is the arctangent, or the inverse tangent. So inverse tangent of u, evaluate this from 1 to 2 divided by pi. Then simplify things further, so 1 divided by 4 minus pi cubed divided by 4 times pi squared plus 4. Then if I actually calculate the bounds over here, so what I have is minus 1/2, and then now multiply, so it's going to be negative pi divided by 2, and then subtract 1, or actually this is going to be a plus 1 over here. And then next thing is plus 1/2, and then multiply by, so put this input in, so we have the inverse tangent at 2 divided by pi. It's not exactly a well-known value, so we just leave that the way it is. However, what is well-known is that if I plug in 1 back into here, it's actually just going to simply reduce to just pi divided by 4. All right, so last step is pretty simple. Now we can actually just simplify some stuff over here. So we're actually going to get everything together, so 1 divided by 4, and then just distribute the -1/2 into the 1. So that means first I have is, well, also we have a pi over 4 over here. So put that back in, and then put this back in over here, and then reduce that. So that will yield us with pi divided by 8. Then next is going to be a subtract of 1 divided by 4, and then we're filling the gap. So it's 1/2 inverse tangent at 2 divided by pi, and then simply just subtract pi cubed divided by 4 times pi squared plus 4. And so that is actually our final answer to reduce. That's as simple as it gets, which is our given our final value for our given integral that we want to calculate over here. So looks like a long value, but that actually comes out as its closed form, or not necessarily a closed form, but the closed value of this integral over here. Everything, you know, looks with some easy techniques, but you have to, you know, learn how to get creative. That's one of those, you know, tricks you gotta learn. So yeah, that's pretty cool if you ask me.